how many factors for 72? How many factors for 72 exist whose HCF it is 6? Whose HCF is 6. We did HCF 1. Two numbers are said to be co-prime if their HCF is 1. That one I removed. Now the question is, how many factors for 72 exist whose HCF it is 6? Listen carefully, sir. First concept. He is telling, first take 72. What are the factors of 72? Factors of 72 will be, 1 will be a factor of 72, 2 will be a factor of 72, 3 will be a factor of 72, 4 will be a factor of 72, 6, 8, 9, 12, 18, 24, 36, 72. These are the factors of 72. 72 can be written as a power of prime basis, which is 2 power 3 into 3 square. 2 power 3 into 3 square. Now he is telling, in these numbers, pick in these factors, pick two factors such that HCF of that two numbers it is 6. HCF of that two numbers it is 6. Now one way is to find out that two numbers I am picking. HCF of 6 comma 12 it is 6. One way. I need to pick two factors among the factors of 72 whose HCF it is 6. One way is to solve it like this. HCF of 6 comma 12 is 12. HCF of 6 comma 18 it is 6. HCF of 6 comma 36 it is 6. HCF of 6 with any natural number, 6 with 72 it is 6. Like this I will get the cases, but these is nothing but a counting case. These is nothing but a counting case. We are doing counting. I don't want to do counting. Counting will take a lot of time. So let us solve the problem logically, understanding from the previous problem. Now see here, how am I solving? First problem I will do slowly. Second and third we will do very, very fast. First one. What is the number given? Number given is 72. 72 can be written as 2 power 3 into 3 square. I need to select two numbers. Let the numbers be A and B. Let the numbers be A and B. Because 72 contains 2 prime bases 2 and 3. This will have 2 power x1 into 3 power y1. B also will have 2 power x2 into 3 power y2. We do not know the numbers A and B, but we know the numbers HCF of these two numbers, it should be 6. It should be 6. 6 is 2 power 1 into 3 power 1. 2 power 1 into 3 power 1. The definition of HCF is, HCF, it will always take the lowest power of the common prime basis. HCF always takes the lowest power of the common prime basis. That means, based on what we discussed till now, minimum of x1 and x2, minimum of x1 and x2 it should be 1. What is the other case? HCF takes the lowest power of the prime basis. Minimum of y1 and y2 it should be 1. I hope the idea it is clear. So x1 and x2, what are the limits? It can start with 0 and it has to end at 3. Why? Because 72 is 2 power 3 into 3 square. Similarly, 0 less than or equivalent to y1, y2 less than or equivalent to 2. y1, y2 less than or equivalent to 2. Why? Because to get 72, power of 2 should be 3 and power of 3 should be 2. Till here clear? In the previous case, co-prime. So power lowest value is 0. Here it is HCF is 6. 6 means 2 power 1 and 3 power 1. So x1 can be lowest. If x1 takes 1, If x1 takes 1, it is lowest. x2 can take 1, x2 can take 2, x2 can take 3. If x2 takes 1, if x2 takes 1, so what it will be? It can be 1, 2 or 3. 1 comma 1, 1 comma 2, same process. 1 comma 2, 1 comma 3. Next will be 1 comma 1, 2 comma 1 and 3 comma 1. 1 comma 1, it is duplicated. So how many cases? 5 cases. How many cases? 5 cases. Similarly, minimum of y1 and y2 should be 1. If y2 it is 1, y1 it is 1, y2 should be greater than or equivalent to y1. It can be 1 or 2. If y2 it is 1, it can be 1 or 2. So 1 comma 1, 1 comma 2. 1 comma 1 and 2 comma 1. 1 comma 1 it is duplicated. So how many we got? 3 cases. 5 into 3. 5 into 3 it is 15 cases. It is an ordered pair. 7 cases here, 7 cases here, 1. It is A equivalent to B. It is A less than B. It is A less than B. So answer for this question, it is 7. Answer for this question, it is 7. I hope the idea it is clear. Only with 6. Only with 6. I got 612, 618, 624. 624 also we should have written. 624, 636, 72. 1, 2, 3, 4, 5. Total we got 7 cases. That means there should be another 2 cases which can come. Let us see what is that cases. For example, 4 and 24, it is 4. 4 and 36, it is 4. So here only somewhere it will be there. So this will be HCF of 3 comma 12, 3 comma 18. HCF of what are all the numbers that will be possible. Otherwise, we can substitute the cases. We will get the cases right. 1 comma 1. 1 comma 1 is 2 power x1 it is 1 and 2 power x2 also it is 1. Okay. And 2 power like this. We will do the cases. 2 power 1, 2 power 2. 2 power 1, 2 power 3. 2 power 3, 3 power 1. Combined with y1, y11, y11, 1 means 3 and 3. So 2 3s are 6, 4 3s are 12. 6 and 12, we have taken the cases. 1 and 2. 1 and 2 will be 2 3s are 6, 4 9s are 18. 6 and 18, we have taken the case. Like that, you can do the cases. Some other 3 cases also, you will get it. I hope the idea it is clear. In case if you want the cases, because it is the first problem. What are the cases? X1 it is 1. Y1, X2 also it should be 1. So it is 2 power 1. Or it can be 2 power 1, 2 power 2. It can be 2 power 2, 2 power 1. I hope you are understanding what am I doing. 2 power 1, 2 power 3. Next will be 2 power 3, 2 power 1. What are the other case? So 1, 2, 1, 2, 3, 4, 5. So 5 cases. It is multiplied by 3 power 1, 3 power 1, 3 power 1, 3 power 2, 3 power 2, 2 power 1. So all the other cases, we will get it. Now one by one we will see the cases. Otherwise, conviction will not be had. So 2 into 3, it is 6. 2 into 3, it is 6. HCF of 6 comma 6. 6 comma 6, one more case. HCF of 6 comma 6, it is 6. One case, but we have eliminated equivalent to, so another case. 2 3s are 6. 2 9s are 18. 6 comma 18, we have taken the case. Next case, 2 9 2s are 18. 2 2s are 4. 4 comma 18. 4 comma 18. 4 comma 18. 2 into 2. 2 into, it will be, which case it is? 2 into 3 square. 9 2s are 18. It will be, it is 3 square, right? 3 power 1. So 9 twos are 18, 3 twos are 6, 6 comma 18 we have taken. Like that, take cases. 2 threes are 6, 4 threes are 12. 2 threes are 6, 4 nines are 36. 2 nines are 18, 4 threes are 12. 12 comma 18. 12 comma 18 is another case. 12 comma 18. I hope you are able to understand. 2 into 9, 18. 4 into 3, 12. Next one it will be 4 3s are 12. 4 9s are 36. 36 comma 6. Already we have taken. 2 into 9, 18. 8 into 3, 24. 18 comma 24. 18 comma 24. 6 3s are, 6 4s are. So 1, 2, 3, 4, 5, 6, 7. This case is both are equal. So I have taken a question. Just write down the question, distinct factors. Idea is to tell you that all the 7 cases exist. Idea, it is clear, nothing you have to do. HCF of A comma B, it is 6. 6 is 2 power 1 into 3 power 1. Lowest power of x1 and x2, it has to be 1. Start with 1, x2 can take 1, 2, 3. x2 can take 1, x1 can take 1, 2, 3. I hope the idea it is clear. So not only the factors for 72 which are co-prime to each other, you can take the factors for 72 where the HCF is beyond 1. I hope the idea it is clear. 2 more questions I will solve, then the idea will be perfectly clear. These are all very, very good CAT level questions, sir. How many distinct factors? How many distinct factors? How many distinct factors for 360 has HCF 30? Has HCF 30. How many factors you have to take it from 360 such that HCF of that numbers will be 30? Very interesting approach. Listen carefully, sir. How many distinct factors for 360 has HCF 30? Solution. Listen carefully, sir. 360 as a power of prime basis. 2 cube into 3 square into 5 power 1. 2 cube into 3 square into 5 power 1. So I have to take 2 factors. HCF of A comma B, it is equivalent to 30. HCF of A comma B equivalent to 30. Listen carefully, sir. Write down this point. If the variables are not present, in the question, then we are doing unordered pair. Don't get confused. What is unordered pair? Reverse case. A comma B is equivalent to B comma A. Reverse should A comma B is equivalent to B comma A. That means reverse should not be taken. HCF of A comma B, it is the 30. 30 is given as a prime basis. 2 into 3 into 5. 2 into 3 into 5. Now, one by one, step by step, we will get the answer. A we don't know. B we don't know. I want the HCF of A comma B. HCF of A comma B is given by 30, which is 2 into 3 into 5. So A will have 2 power x1, 3 power y1, 5 power z1, 2 power x2, 3 power y2, 5 power z2. HCF always takes the lowest power of the given prime basis. Lowest power. Case number 1. Minimum of x1 and x2. Minimum of x1 and x2 has to be 1. Case number 2. Minimum of y1 and y2. It is 1. Case 3. Minimum of z1 and z2. It should be 1. I hope the idea it is clear. But x1 and x2, it is 360. 360 means power of 2 maximum, it is 3. 0 less than or equivalent to x1, x2 less than or equivalent to 3. y1, y2, it will be 0 less than or equivalent to y1, y2 less than or equivalent to 2. 0 less than or equivalent to z1 comma z2 less than or equivalent to 1. Less than or equivalent to 1. This upper limit will help us to stop after a value. Minimum of x1 and x2, it is 1. That means if x1 takes 1, x1 is taking the lowest power. So x2 can take any value greater than or equivalent to 1. So it can go up to 3. If x2 is taking 1, x1 can take any value greater than or equivalent to 1 up to 3. 3 plus 3, 6. 1 comma 1 is duplicated twice. 5 cases. I hope the idea it is clear. Minimum of y1 and y2, it is 1. That means lowest power can be given to y1. So y2 can take 1 or 2. If y2 is taking 1, it can take greater than or equivalent to 1. 1 comma 2. 4 cases, 1 comma 1 is duplicated. Z1 and Z2, it is 1. If Z1 is taking 1, Z2 will take only 1. Upper limit itself is 1. So reverse case 1, 1. It is duplicated, so only 1 case. So 5 into 3 into 1. Total 15 cases exist. 15 cases, it is an ordered pair. 15 cases, it is an ordered pair. Question variables are not present in the question. One case where A is equivalent to B. HCF of 30 comma 30. 7 cases A is less than B. 7 cases A is greater than B. Distinct, this case should not be taken. In an unordered pair, reverse is not allowed. Unordered pair, reverse is not allowed. Beautiful question, sir. Very easy question. Most of the students think that it is a difficult question. But if you understand the question, HCF, it is 30. 30, it is 2 into 3 into 5. Very beautifully I used the definition of HCF. HCF always takes the lowest power. So if x1 takes 1, x2 can take greater than or equivalent to 1, 2 till 3. If y1 takes 1, 1, 2, y2 can take 1 comma 2. One more problem we will solve. This is an level 3 LOD, level of difficulty 3 question, but very, very good question to understand our concept. I hope it is clear. How many distinct factors for 360 has HCF 30? One more question by taking some examples. Congruence modulo theorem. Congruence modulo theorem. Congruence modulo theorem. Now see here. What is this congruence modulo theorem? Suppose I am doing HCF of 3 comma 5. 3 and 5 are co-prime numbers. Co-prime numbers HCF, it is 1. Co-prime numbers HCF, it is 1. Now listen carefully. I am taking 3 and 5, 2 numbers. These 2 numbers are congruent under co-prime set. These 2 numbers obey the property of co-primes. 2 numbers are said to be co-primes if their HCF is 1. HCF of 3 and 5, it is 1. Let me do a modulo addition. What is 5 plus 3? 8. If 3 and 5 are co-prime to each other, can I say 3 and 8 are also co-prime to each other? That means still the HCF will not change. I can write it as 3 comma 5 plus 3. In both the cases, HCF of 2 co-primes, it is 1. What I'll do is, next one. So instead of doing it individually, HCF, individual with the addition of 2 numbers, HCF does not changes. It is even equivalent to the second number with the addition. 5 comma 5 plus 3. 3 comma 8, it is 1, and 5 comma 8 is also 1. 8 is 5 plus 3. Let me do a subtraction. If I do a subtraction 2, So HCF of 3 comma 5, it is 1. HCF of 3 comma 5 minus 3. What is HCF of 2 comma 3? HCF of 2 comma 3, it is again 1. It is also equivalent to HCF of 5 comma 5 minus 3. 5 comma 5 minus 3. HCF of 3 comma 2 is 1. HCF of 5 comma 2, it is 1. But are these both co-prime to each other? Are these both co-prime to each other? 2 is an even number, 8 is an even number. Can HCF of 2 even numbers, can it become an 1? HCF of even numbers, it is always 1. Now, very important property. Please write down. If two numbers are congruent under some property, here I took a co-prime property. HCF of A comma B can also be written as HCF of A plus B. Individual numbers HCF, it is also equivalent to individual numbers with addition of two numbers, B comma A plus B. It is also equivalent to individual numbers with the subtraction of two numbers, B comma B minus A or A comma B minus A. But may or may not be equivalent to, may or may not be equivalent to, HCF of A plus B comma B minus A. Very important property. Extremely important property. Very important property. Property says, now see the heading, congruence modulo theorem. If two numbers are congruent under some property, in this case it is a co-prime property. If I do any modulo addition, 5 plus 3, 8, 3 with 8 or 5 with 8, congruence does not changes. What is the definition of congruence here? Two numbers are co-primes. If I do modulo subtraction, 5 minus 3, it is 2. 2 comma 3 and 2 comma 5. Still they are congruent to each other. That means, can I say HCF is congruent under modulo addition. And it is also congruent under modulo subtraction. If two numbers HCF, if we have to find, instead of doing the HCF of two numbers, individual with the addition of two numbers you can do, individual with the subtraction of two numbers you can do. But addition and subtraction of two numbers, don't do. It is not equivalent to HCF of 2 comma 8. Please make a note, sir. Next 1.5 hour, each and every question is extremely important. Very important, sir. HCF of A comma B. Again, I am repeating this statement. If two numbers, if you have to do HCF, you can do individual number with the addition of two numbers. You can do HCF of individual number with the subtraction of two numbers. Addition and subtraction of two numbers don't do. In all these cases, HCF, it is unaffected. HCF does not change. If I do A comma A plus B, B comma A plus B, A comma B minus A, B comma B minus A, may change, may not change for A plus B comma B minus A. This is a very popular theorem under HCF, congruence modulo theorem. Why that name came into picture? If two numbers are congruent under some property, it is co-prime property. If I do modulo addition, still it will be congruent, still it will be co-prime in this. If I do modulo subtraction, still it will be congruent. Are you all with me? This is the first important concept. First important key point. Second important concept. How to find out the HCF using minimum difference method. HCF using minimum difference method. First of all, why should we use minimum difference method, or how minimum difference method can help us to solve the question? Minimum difference method. Minimum difference method. In our school standard, we have discussed this one. HCF of, for example, 9, 12 we have to do. There is a method that is taught in our school. That is the long division method. I took the largest number. I divided it with the smallest number. I divided it with the smallest number. 9 ones are 9. Subtraction I took 3. I shifted this number here. 3 3s are 9. It is 0. What is this number? This is nothing but the 12 minus 9. 12 minus 9. Keep it in loop, sir. Next one. HCF of 9, 12 and 15. 9, 12 and 15. Or 9, 12 and 27 we will take. 9, 12 and 27 we will take. You will understand why the minimum difference came into picture. 9, 12 and 27. HCF of 9, 12, 27. Now see, here 3 numbers are there. What you do is, you take the first with the last. Largest number is 27. I am dividing with the smallest number. 9 3s are 27. Remainder 0. Remainder 0. Wherever the remainder is 0, it is called the HCF. HCF of 9, 27, it is 9. Whatever the HCF that you got for the first and third, do it with the second. 9 is the HCF for the first and third. Do it with the second. 9 ones are 9. Remainder, it is 3. 3 3s are 9. Remainder 0. 3 3s are 9. Remainder 0. Now observe these 2 questions. You can get a lot of very good observations. 9, 12 and 27. Find out the minimum difference. 9 and 12, it is 3. 12 and 27, it is 15. 27 and 9, it is 18. What is the minimum difference? 3. Does 3 divide 9? Yes. 3 3s are 9, 3 4s are 12, 3 9s are 27. So minimum difference is, suppose a collection of numbers are given to you. Collection of numbers are given to you. HCF of A1, A2, A3, it is given to you. Take the minimum difference value. Take the minimum difference value. Minimum difference value among A1 minus A2, it could be A2 minus A1. A1 minus A3 or A2 minus A3. Then apply the factors. For that minimum difference value. Answer is nothing but the factor of the minimum difference. Factor of the minimum difference. The second example will give a clarity. 9, 12, 27. Finally answer I got because of 12 minus 9. Wherever the remainder it is 0, this will become a factor. This will become a factor. This will become a factor. I hope the idea it is clear. HCF of 9, 12, 9, 12, 27. Example. Suppose 4, 6, 22 it is there. 4, 6, 22 it is there. You don't need to do a long division. Take the smallest difference. 6 and 4, difference is 2. 6 and 22, it is 16. 22 and 4, it is 18. Smallest difference is 2. Check whether 2 divides every other number. 2 2s are, 2 3s are, 2 11s are. Answer can be written as 2. Answer can be written as 2. I hope the idea it is clear. Minimum difference.